Hi, I'm Casey Steyl of student number 1827996, and I'm going to give a brief introduction into our project and some of our design choices for our project. So, a person with polyps develops a nodule on their vocal cords, and this nodule usually becomes very present when they are asked to emulate higher frequencies of their vocal spectrum. So what would happen is, as a healthy person was emulating a frequency, their vocal cords would touch and vibrate. However, with a person with nodules, their vocal cords would actually be blocked by a node on their vocal cord, and it would not make contact with the other side, and so air would be able to come through, and the vibration just wouldn't be there that a healthy person would have. And so for us to emulate this, we decided to use a ruler, and we would fix it to a table and extend it off the table and have a weight on the end just so that we can measure lower frequencies. If the ruler had no weight, it would move much too fast, and we would have to change our sampling rate, and it would be much more complicated. So we decided to keep it simple and emulate the frequencies that we wanted using the weight. So what we would do for the healthy person is we decided to measure 5 different frequencies, and by that I mean 5 different lengths that the ruler is off the table. So the ruler would be off the table, and we would displace it, and it would vibrate, and would move it shorter and shorter to emulate higher frequencies. It would move faster and faster. And for the healthy person, in their frequency domain, you would see each of the frequencies of the 5 different lengths of the ruler, just to emulate a person singing 5 different notes. However, to emulate a person with polyps, we measured 3 frequencies and left out 2 of them. So we measured the lower ones, since polyps often affects the higher frequencies, and we would shorten the ruler length, getting towards higher frequencies. But for the last 2 ruler lengths that we did for the healthy person, we did not do for the unhealthy person, just to emulate how a person with polyps wouldn't actually present those frequencies, since it would be blocked by the polyp or the nodule. And that way we show how the polyps would affect the vocal cords. And another thing to note with our methodology is, when a person were to sing a note, it would stay at that frequency. However, with our ruler method, the only problem that we have is we have a bit of dampening, where if you displace the ruler and it vibrates, it kind of starts to slow down. Where with a vocal cord, you can just sing one note and keep it at that frequency. Yeah, so I'm gonna pass over to her now for the visual demonstration of the project.
This is how we're going to be simulating a vocal signal. Please flick it. Yeah, so that will be a simulation of vocal cords, folds, and we'll be recording it now at different frequencies, 5 different frequencies. So I'm just gonna run the program on MATLAB. Okay, go. 175. Next. 980.
What?
90.
90.
Yep. Next one's 220.
Wij zien naartoe weer.
Okay, next one is 240. Next one's 280. How we're achieving the different frequencies is by lengthening how much leverage we give the ruler. And here you can see the 4 different peaks. 5 different peaks. 1, 2, 3, 4, 5 of the different frequencies. So to simulate a person with vocal polyps on their vocal folds, we're going to be doing the lower 3 frequencies, so that since a person with a polyp on their vocal folds will most likely have issues getting to higher frequencies. And I am starting the program now. Okay, go. I'd like to note that if this was a real person, there would be 240. There would be no damping on the vocal cords, since they have consistent amplitudes of voice. Here you can see that there are peaks, only 3 peaks at the lower frequency values, due to the fact that this person would not be able to reach the higher peaks and their voice would cut out due to the pressure on their vocal folds.